In the last video in this series of upgrades to my CNC router, I promised that we'd be putting the VFD in an enclosure and getting everything wired up properly. And we're going to get to that. But before we do, I want to talk about why I even decided to upgrade to a water-cooled spindle in the first place. Because this didn't really start as an upgrade. It started as more of a problem. I started to hear the bearings in my router getting noisy again. And I'm familiar with that sound because I've been through this more than once. I've had to replace those bearings on multiple occasions, especially after long jobs, 6 or 8 hour 3D carvings, where they just get warmer and warmer over time. So for me, there were really 3 main reasons that I chose to upgrade. The first one was simply to improve power. My 2.2 kilowatt water-cooled spindle is rated at 3 horsepower, which is about a 50% upgrade from the 2 horsepower router that I've been using for many years. But power alone wasn't really the reason. It had more to do with resilience and reliability. Like I said, I've had to replace the bearings in that router more than once. But with a water-cooled spindle, I should be able to run for hours, even days, as long as I keep the coolant under control. This can be as simple as throwing some ice in the reservoir if I need to, or maybe getting a little more fancy and installing a chiller at some point. We'll see where that goes in the days to come. The last reason I chose to upgrade was really about improving my workflow. With this new spindle, the control software will be able to turn it on and off and set the RPM automatically through G-code. For years I've been setting the RPM using the dial on the router, and it's really just an approximation. Now, I'll be able to put in a specific number directly into the software, and those settings for RPM will actually mean something. And a big part of that is repeatability. For me at least, the whole point of having a CNC router is to be able to make identical parts and get consistent results. Being able to control RPM through code eliminates one more variable and makes the whole process that much more repeatable. So those are the main reasons behind this spindle upgrade. Now let's get the VFD set up. Alright, before we go any further, let's take a minute and talk about electrical safety. I'm going to shut the VFD off right now, but that does not mean it's safe to touch. You can see the lights are still on. This unit stores energy in its capacitors and can hold a dangerous charge even after the power is removed. VFDs are not low voltage electronics. This is tied directly to mains power and it could seriously injure or even kill you. So always disconnect the power before wiring or servicing and give the unit time to discharge. You can see the numbers are still lit up. And verify it with a meter if you have one, just to make sure there's no power there. Don't just assume that it's safe. And if you're not comfortable working with electricity and electrical systems, stop here and get help from somebody who is qualified. Remember, no project is worth risking your safety. All right? Well, let's keep going. Before we can wire anything up, I needed to get the enclosure ready. I decided to keep the VFD separate from the other control wiring in its own enclosure. And there were really 2 reasons for that. One, it keeps the VFD closer to the power source. And 2, it helps keep all the EMI noise from the VFD far away from the rest of the control panel. So with that in mind, I started getting the enclosure prepared. First, I cut in a couple of vent openings and installed filtered vents, one on each side, to get some cross airflow through the box. The VFD itself already has fans that move air across the heat sinks, so this is really just to let the warm air escape and pull cool air in. After that, I drilled the holes for the cable glands. I installed one for the spindle cable, one for the main power, one for the control wiring from the control panel, and then I added an extra one for future expansion or upgrades. Once everything was drilled and installed, I mounted the enclosure to the wall in a convenient location. So let's start at the source. The spindle runs on 240 volts of AC power. Luckily, I already had a 30 amp outlet for my plasma cutter, right near the machine. So what I did was order a 12 gauge cord for the setup, and then it was just a matter of swapping out the breaker. I can still run the plasma cutter at 30 amps just by using the extension cord from my welder. From there, I ran the cord through some PVC conduit. Nothing fancy, just for mechanical protection behind the toolbox. And then for proper strain relief, I used a cable gland where it enters the disconnect. Even though the plug is only a couple steps away, and the breaker is maybe 12 or 15 feet away, I figured it was just good practice to have a disconnect right here at the machine. From that disconnect, the power feeds into the VFD enclosure and connects to the line, neutral, and ground terminals on the VFD. Now this part actually confused me a little bit at first, because in my mind, 240 volts is 2 hot lines and a ground. So when I saw line and neutral on the VFD, I thought maybe I had the wrong unit. But what I found is this. In other parts of the world, like Europe or Asia, 240 volts is supplied more like our 120, with a line and a neutral. So in this case, I just connected my 2 hot legs to line and neutral, and then the ground to the ground terminal. Wiring the spindle itself is pretty straightforward, but getting the right cable is a really important first step. The cable needs to be at least 14 gauge, and it should be properly shielded. This is one of those areas where it's worth spending a little extra money, because the VFD is the biggest source of EMI in the whole system. One important thing with the spindle cable, the shielding should only be connected on the VFD side. You don't want to connect the shielding at the spindle end, because that can create unwanted noise or ground loops. Once you've got the right cable, the wiring itself is pretty simple. You're just connecting the U, V, and W terminals on the VFD directly to the 3 power terminals on the spindle. The order isn't especially critical, but it will determine the direction of the rotation. So if it spins the wrong way, just swap any 2 of the wires to reverse it. And of course, your ground wire, typically green or green with a yellow stripe, goes to the ground terminal on the VFD. One thing that is important to check is that the spindle itself is actually grounded properly. There are reports that some of the Chinese spindles aren't always properly grounded from the factory. So I verified that with a continuity tester, just to make sure there was a good connection between the ground pin and the body of the spindle. Also, inside the enclosure, the cable shielding needs to be terminated to the equipment ground, and that ground also needs to be bonded to the enclosure itself. As you can see here, the bonding lug that connects the door to the main body of the enclosure, well, it wasn't exactly installed very well. It actually twisted off with just a small amount of tightening force. So I'll need to go back and fix that, probably with a through bolt or maybe a rivet. The last piece of this was running the control wiring. I ran 3 22 gauge shielded cable pairs from the control cabinet into the VFD enclosure, along with a 12 gauge green grounding conductor to bond the 2 enclosures together. Of those 3 cables, one is for the spindle start and stop, and one is for RPM control. And the third one, I just ran for future expansion. The start and stop cable connects to the run terminal on the VFD and common. The RPM control cable, coming from a 0 to 10 volt analog signal from the control panel, connects to the analog input on the VFD and the analog common. Lastly, we need to get the VFD settings configured correctly. I did have a little bit of trouble here at first, mostly because I had no experience with a VFD going into this. Now for the moment of truth. I have my spindle wired up to my VFD and I'm about to plug it in and see what happens. We have lights. So I think I was able to get it running out of the box, but after a few seconds, it would shut itself off and throw an error. So it took a bit of time digging through the settings and figuring out what needed to be adjusted. One of the biggest mistakes I made was changing the frequency setting from the default of 50 to 60 Hz, thinking in terms of ball power here in the United States. But that setting actually needs to match the spindle, which in this case is 400 Hz. Once I corrected that and made a few other adjustments, it ran perfectly. There are a handful of other settings that needed to be configured as well, but rather than go through all of them here, I've put together a full list of exact settings I used, and I'll have them available as a download linked below. Alright, so with everything wired up and the settings dialed in, it's time to see if it actually works. One thing to note, I'm still running the coolant pump separately for now. I've just got it plugged in manually, because we definitely don't want to run this thing without coolant flowing through it. This is temporary though. I just got my AXBB controller in, which is going to let me automate everything. Spindle control, coolant, all of it, through the software. So that'll be coming up in the next video. Alright, let's start it up. Nice and smooth. And that's full speed. Just for comparison, this is the router at full speed. Here's 2400 RPM with a router. So yeah, quite a difference. Oh, so much better. So much better. Now obviously when it's cutting the material, there's going to be some noise associated. But a lot of what I hear as I'm working is just that router just whining away hour after hour. So now it's smoother, it's quieter, and having actual control over the RPM through the software is going to make a big difference. So overall, I'm pretty happy with how everything turned out. Still got some stuff to finish up, but Spindle and VFD are up and running, and I'd call that a success. If you want to see how everything works once everything's automated, go ahead and subscribe so you don't miss out. Just got to finish up my new control box, which is coming up in the next video. And if you're setting up something like this yourself, I've got a full list of the VFD settings I used linked below. Be sure and check that out. Well, I guess that's all for this video. Until next time, stay safe.